Okay, welcome, folks. The second edition of Cloud Natives UK. As hopefully you might be aware, virtual collaboration between Cloud Native Manchester, Cloud Native Edinburgh, Cloud Native Glasgow, Cloud Native Wales, and Cloud Native Bristol. We're not all represented on the hosting team today, but I think most of us are. So welcome my fellow co-hosts, Guy Templeton, Adrian Moat, Lewis Denham-Parry. How are we doing, folks?
Yeah, good, thanks. You?
Good. KubeCon week, so it's all a bit manic here. So let's move the show on, and before I've got a little intro clip before we introduce our main guest for this evening.
Welcome. All right. Hey, well, thank you for coming to my talk. And if there's anyone that wants, if the demo gods are listening, let's hope that they are watching over us today for this talk. If you hear us up there.
That's very cool. For any of you who haven't seen that, that's Justin's latest piece of work. So Justin Garrison, welcome to Cloud Natives UK. Thank you for joining us by the magic of technology. I almost feel like we're in a Doug Engelbart demo.
I mean, it was amazing, right? Like everything they did in that demo is like, we're just living it. And,
yeah, absolutely. This is it, right?
Yeah.
So for any folks who are watching who have never seen that video, it's got a fantastic overdub soundtrack there from Justin to change it into being about Kubernetes. But it's from, I think, 1968, that Doug Engelbart demo of the NLS system, where video conferencing, hypertext, the mouse, you name it.
The mouse was like a footprint in that whole thing of just like, oh yeah, we have this little thing, it moves around the screen. Oh, look at, did you see the keyboard like chord thing he had to type was amazing. I was like, I want that still. Like, where's my, I had a longer version of that talk that went into each of those things and made fun of them in Kubernetes space, where like the keyboard thing was actually for YAML, and like each space was like, I was like, hey, if you do this chord, it's 4 spaces. If you do this, I was like, you know what, like I'm gonna trim it down. But yeah, no, I had the idea when I watched it, a while ago, and it was just like, you know what, like this fits for a lot of things. And I just kind of wanted to, have fun with it and just kind of like let people experience it as well. Cause like so many people haven't even seen the demo, and it's just amazing to think how many years ago was that? 40, 50, 60 years. Like, it's just like they were doing so many things back then, and we're still essentially doing the same demos today. Like that's
yeah, I mean, it's amazing, isn't it, how few people are aware of lots of the pioneers from that. And I mean, in that era, it must have seemed even more incredible, right? It must have been like total black magic.
I can't even imagine. Yeah.
Yeah, I mean, there's, I'm a big fan of lots of the folks who were around at that time, people like Alan Kay, and, if you read some of the history of like the stuff that happened at Xerox PARC, right, it's just all equally as mind-blowing, really. And lots of those people all floated around between the same labs, and we're all part of the same set of people. But yeah, awesome stuff.
Yeah.
Yeah, thank you for joining us. It's what time is it? You're in LA, right?
Yeah, LA. It's 10 a.m.
Oh, right. So not super early. So
nah,
we're gonna hear a talk from you a little bit later, but I always like to kind of start off by asking folks kind of how did you get into this cloud native stuff? Perhaps give our viewers a little potted history.
I mean, the cloud native specifically was all to solve a problem. We were trying to solve problems at work, and I was trying to solve problems at home. I had too many home lab computers and too many things that I didn't really want to manage anymore, and figuring out not only like, oh, could I offload my electric bill by paying for services, but also could I, like use higher level services? What are the benefits there of having someone else run these things? Because I've worked in plenty of data centers where we're swapping hard drives and racking and stacking and power outages and all those things. We're just like, like, how do we solve higher level business problems? How do we ship value faster? And I found a lot of those solutions in cloud technologies, in open source, in all these areas that I over and over again keep finding new communities and new tools and new places to kind of experience that and to build on top of it. So for me, it just was solving problems over and over again, and then falling in love with communities and the people and the innovation that people with such different backgrounds and different ideas come up with. Like, oh, I know about this technology and I understand how it could solve this problem in a unique way. And then really digging in and talking to those people and hearing their stories.
Awesome. Well, we're going to come back and chat a little bit more later in the show, but I think we ought to get the ball rolling with our first talk of the evening. So bringing on Dan from Equinix Metal. Welcome, Dan. Are we going Dan first? We're going to Andreas first, right? Are you still? We're struggling with some technical problems here.
I'm struggling with all of the technical problems.
All right, we'll come back to Dan a little. We'll come back to Dan in a bit. Let's bring Andreas out instead. Andreas is from Container Solutions. Welcome. Do you want to share your screen, Andreas, and we'll get things kicked off?
Absolutely. Thank you, man. Happy to be here. Nice to see you all virtually. So let me share my screen. As probably you've realized by my accent, that I'm not from Edinburgh, but I'm representing Edinburgh today. Share screen. All right. Yeah.
Okay, you're good to go. I'll drop myself out.
Awesome. Thank you. All right. So welcome everybody to my lightning talk. I'm quite happy to be giving this talk today, and it's actually the first time that we are going to be sharing this information with a wider audience. So it's an exclusive for Cloud Native UK. What I want to share with you today is an open source way that we devised while facing certain issues with a client of ours, Container Solutions. It's a few months that we started with this, but it's evolving very fast. So I think it's going to be a nice teaser for what's to come. Very quickly about who I am. I'm Andreas Krivas. I'm the Engineering Manager at Container Solutions, more of an infrastructure background, but you know how it is. So I've been doing a lot of stuff in the cloud native arena. And I've been with the company for about 3 years now, a little less than 3 years. And recently, I was for the last couple of years, I'm working with a client, a major retail company. And you know how it is with retail companies, especially around certain times over the year, like Black Friday or Cyber Monday, Christmas, summer, all these periods that when sales start, then when you're talking to a retail company, this is their big stress, let's say the major stress periods that they face. This is typically what they work through the whole year to accommodate this kind of periods. So what we understood is that what we're trying to figure out how they prepare their platform in order to cope with this increased load. They said, you know what, we have a couple of people that they manually scale all of our applications to 10 times more a few days before Black Friday, and then we scale it back if we remember to do that after Black Friday. And of course, that sounded very painful for those people and also not very efficient. So they really asked us, how can we make sure that our platform is stable and ready to receive all these huge amounts of traffic during this critical time. And we're thinking about it and saying, you know what, horizontal pod scalers and HPA is a good tool. It's a good way of scaling things, but definitely it can help us scale from 2 to 100 pods in a matter of seconds, right? This is just not easy, not doable. We also we have different applications. We have data stores, we have message brokers, we have stuff that they can't scale the same way that like other applications. And that led us to believe that really trying to scale or allowing things to auto-scale close to that period from an average type of workload, it's really, really risky and not easy to maintain or to manage. So we, of course, that's what we do. What we said, let's automate this. Let's find a way to make this more controllable, more predictable, and more automated. So what we started doing is developing an operator. We called it pre-scaling Kubernetes operator, which is not very imaginative as a name, but I guess it gives the message. Essentially, the goal is to develop an operator that manages a whole platform and maintains a certain state in the cluster level or even at the namespace level. And what I mean by state is a certain number of replicas of the applications that have chosen to be managed by the operator. I'll explain more how it works in the next slide. But essentially, what we're trying to do is that when we anticipate a period with significant traffic that could cause us our platform to run to scale to 10, 20, 30 times more, then we prepare the cluster by declaratively defining the state of the cluster. And then every application will be scaled and maintained to that level. Now, a little bit more of how it works. What this operator is supporting is 3 different types of scaling use cases. There are applications that they should not scale no matter what. For example, persistent stuff, right? And that's why we have an opt-in model. Applications can choose to opt in or opt out to be managed by the operator. Then we have the typical use case, which is we scale an application to a user-defined number of replicas. I'll explain in the next slide how exactly that happens. But also we have a third mode that once we scale to a certain number, then we can allow the application to auto-scale. For example, if you don't know exactly that I need 100 pods or 50 pods, but I need around 50, 60 pods, the operator can manage the pre-scaling like a warm-up kind of function up to a minimum number. At that point, the application can slightly auto-scale, which can work better than having to auto-scale from very low to very large number. We do support also deployment configs. That's why it's also Kubernetes and OpenShift. And like I mentioned, we can do this either at the cluster level or even at a single namespace level. Now, here's another graph, a bit complicated, but I'll briefly go through that. Let's say we have a cluster, we have a lot of namespaces, a lot of applications in that cluster. What we actually use is annotations to inform the operator of what is the desired replicas for the states that we want to apply in the cluster. Let's start with the operator though. We have 3 CRDs. You can read about them in the bottom left corner of the slide. The first and important one is the cluster scaling state definition. This is basically, also you can see it here, this is basically the CRD that defines what are the possible states that the cluster or the namespace we can apply to the cluster or namespace. This is a user-defined CRD. You can put peak state, you can put any type of any number of states that you want. We also have a priority there in case that there are multiple states that are applicable for a namespace. And then we have to reconcile and we have to choose what is the highest priority in order to scale to that one. Now, once we have the definition CRD applied, which is unique per cluster, we have then cluster scaling state and scaling state CRDs. As probably you have already guessed, cluster scaling state applies a state to the whole cluster and all the applications that have opted in to be managed by the operator, and the scaling state, which is on the namespace level. Now let's take a quick example, saying that, all right, we have, for example, here a namespace with a few applications and other namespaces. If we apply first the cluster scaling state, which is business as usual, it will go and scale all the applications to the business as usual replicas, which means here will be 5, here will be again 5, and here 15. If now somebody applies, or if we want to apply a fixed state only on a certain namespace, then the priorities come into play, and only for that namespace it will scale to the peak state. That gives us a little bit more granularity if we have more critical namespaces that need to scale more than others, or need to be in absolutely high priority scaling mode compared to others that might be not that important maybe for that period. That way we can control also different states for different namespaces. That's the overall idea behind it. Some of the key features that we are already implementing, some of them are to come, but we're gonna go soon in production, so it's not gonna be too long. It's important to check the resources available in a namespace in the cluster, right? Because if somebody wants to scale 100 times more, we need to be sure that we have the resources to cover that. So the operator makes sure that there's a check that validates that we have enough resources by checking the resource quotas. If the quotas are not there, give a big warning, still allow scaling, but this is something that always the operator will try to make sense of. Rate limiting, because we also don't want to scale from 2 to 100 in one go, starting with 98 pods like that. This is optional, but the user can choose to have a stepped scaling process that we scale with a certain rhythm, and we make sure that applications are starting up before we scale more. And this is for a more controlled scaling, more safe scaling. Schedule scaler that allows us to schedule the cluster to go to a certain state at a certain date and time, right? Pretty easy. Another idea that we are now thinking about is having individual scalers that are separate from each other that can manage a group of namespaces together. For example, think about multi-tenant clusters that maybe you need to scale only one tenant and not the other tenants. That way you can have a more, even more granular way to scale a cluster. We're implementing an admission controller because one of the things we want to avoid is if an application is managed by the operator, nobody should be able to change the replicas. No manual intervention, no something else. The replicas field is now managed by the operator, right? So we need, for example, that's one use case for the admission controller to make sure that some fields, some updates are not happening that we want. Then we have a dry run option because it's understandable that somebody says, well, I'm too scared to apply a cluster scaling state and affect 20, I don't know, 100 applications. So in this dry run mode, if run through that, you can see what will be affected and how before we actually apply that. And finally, we're thinking about a simple UI for the operators of the cluster to see at any given time what is the state of every namespace and what is the state of the cluster in order to make sure that everything is handled properly. And of course, more to come. It's still under development. We started in January, and we have already a first pre-release out. We are now in the spot where we try to get real user feedback from our client. Of course, we're looking to grow another community that the operators is already in a good state. And to make this even more clear, what is the target that we have in July? Actually, we target to go to production with the client release. So that's going to be quite interesting. And I hope not with weird events, but yeah, the operator is growing very fast. If you're curious about it, it's open source in Kernel Solutions GitHub. Feel free to contribute. We have a quite not big, but we have a big enough team. If you have more ideas about what this operator could do or where it could help, and I would really appreciate any feedback if you think it would be useful for your use cases or your clients. And with that, that was my talk. Thanks everybody, and happy to answer your questions.
Awesome, thank you, Andreas. Let's just get some more folks back in here. So you can post any questions, comments all the way through the show in the comments box on YouTube, and we'll pick them up at this end. Anybody here got any questions for Andreas before we?
I'll say that I love this. This is like, it solves a problem that I've had in the past. And a lot of times in Kubernetes and in the cloud, we focus on reactive scaling. And we say like, oh, well, it'll auto scale. Like it'll do its thing. Like I'll see failed requests, or I'll see timeouts, or I'll see something bad happen, and then I'll add more capacity. And you can sometimes adjust that with, response times that are like, oh, it's getting a little slower. You could do it with how many requests are coming in. CPU and memory is kind of a odd way that we've done it forever. But that's just like, you could scale on those metrics as well. But having something that's Kubernetes native to just say like, hey, I just need to pin this at this scale because this is coming up. And I just want to make sure that something happens. When I don't know if anyone from Manchester is here from the Disney streaming team. I'm representing today when we shipping Disney Plus, like, was a big deal. We had 10 million signups in a day, and we weren't reactively scaling for that. Like we pre-scaled that, and we let it scale up, and we let it sit there scaled to make sure what was going to break, any edge cases that we didn't expect. So that sort of stuff of like, hey, I know this big event is happening. I know I'm going to get a lot of traffic. Like being able to define some sort of base limit and say, okay, now start here and then scale up. That's just a great model that people are missing in a lot of cases where they think, oh, it'll auto scale after the fact. I'll wait for a failure. I'll wait for a node or a pod that can't be scheduled, and I'll add nodes. It's just not fast enough sometimes.
Great point, Justin. Yeah, thanks for that's exactly the idea behind it, and we felt also that pain because we were with a client during Black Friday, and you can imagine how stressed people were. Do we have enough capacity? Did we scale the applications to the right number, or was there any mistake? And it was very chaotic, and this kind of thing felt like a natural way to go.
Yeah, I mean, I think it's interesting now. We're in an era where businesses launch into massive scale, right? I mean, in some ways, you look at sort of Amazon and Netflix's trajectory. They had quite a long time before they had to deal with gigantic scale, as those sectors were kind of ramping up. But I mean, when Disney Plus launched, that was like from 0 to the dials on 11, like straight out the box, right?
Yeah, I had an old talk of from 0 to 50 million users, which was 6 months. Was like that was how many signups, and it was crazy for that first 6 months of just like that's how many people were coming. And obviously there's a lot of hype with that. Like you need marketing, there's all this stuff, but like the big bang launch is like what a lot of people want now. And that like they're going after that, and they don't understand possibly the system requirements of that sort of, instead of having those private betas and those invite only sort of trickle out effects, like you can manage your scaling by doing those things. But having something like this where you could just say like, I want to launch all at once, or a Black Friday or whatever, like big day that you don't have control over. It's a holiday, whatever the case, like you need to just be able to handle that.
Yeah, very cool. Very cool. So let's talk a bit about KubeCon, shall we? It's obviously a big week. It's certainly a big week for me, which explains why I'm slightly frazzled at the minute trying to run this live stream. It's who's been watching? What have you been watching? Lewis, I know you've been involved with a lot of stuff already.
Yeah, so I was part of the Capture the Flag event for Security Days. So for about 8 hours, we were allowing people to have access to misconfigured clusters. So we shipped them credentials as safely as we could via Slack DM, so that they had access to a 5-node cluster, and they'd have to figure out where the flag was. And it was to help understand security and what to do. But yeah, within about 8 hours, we spun up just over 500 clusters, which after you've mentioned the scale just there, Justin, it kind of feels like, oh, nothing now. But for me on that day, gee whiz, I aged dramatically. And then, but it was really good. And the community, again, it was great just working with so many people and getting people to pop out their first containers. It was super awesome. And I got to go on a couple of panels as well. So that's quite fun for me. And since then, I have been recovering. In my old age, I don't just recover overnight. I need about 4, I might need a couple of weeks, to be honest, after this one. So, yeah.
Yeah, I mean, it's almost, I find these virtual events somehow more tiring than the physical ones. I don't know how everyone else feels about that.
Well, I just made my daughter a bath as well. So it's a case of, I've got my real life, literally, well, there's my clothes there, as we already know. And then there's like my bathroom there. And it's just, I'm looking forward just to being away and seeing people when it's safe to do so, and just having that focus. But equally, but it is nice. The best thing about this, though, is it's lowering the barrier to entry. We don't have to fly across to Barcelona, Copenhagen, or somewhere else. And it's for people in the edge cases where it's the case of if you can't afford to travel, if you've got families that you need to look after, at least you can get to these events, and at least that you can be part of this community as well. The hallway track and the Slack and stuff like that is great.
So you also gave me the biggest laugh on Twitter today, Lewis, and you were obviously never going to get away without explaining this today. This exciting news about you bought an electric skateboard, and then found out it was a ceiling light. What?
Yeah. So, like, we've all had this midlife crisis where we decide that we want to skate again, and so I've moved onto a hill, and so I can skate down the hill fine, but it's for pumping back up a hill it's not on. So I've been looking for an electric skateboard, but sadly I could buy a small car for the same price as one. So I saw this board online for about 40 quid. So I'll give a go on that. And when I unboxed it, I found out that it was actually a ceiling light. I'll bring it for the end. The last talk I'll bring it, and so that's my life.
So this is literally just a skateboard that someone has drilled 3 holes in and put some light bulbs in the bottom of, right?
No, it's been really well done, to be fair to them. They've done a great job. It's lights everywhere. The wheels don't turn anymore because they've been turned into LEDs. So functionally, it's not a skateboard. It is a light. But hey, you don't win them all. You don't win them all.
Indeed. I think we've all done that misunderstanding things on eBay problem. So back to KubeCon. Justin, what have you been watching so far? What's floated your boat?
I have a lot of people I know giving talks, and I love like seeing them succeed. I honestly have not watched a single talk live yet. I hang out in the hallway track. I hang out in social media, and I basically go through Sketch and I find all the talks I want to see later, and then I binge watch them on YouTube. It's typically like my workflow of like, same thing with when I go to a conference in person. I don't go to a lot of talks live. I hang out in the hallways. I love talking to people and meeting new people. And if it's someone that like I want to, support, I'm going to go to their talk. I'm going to be there in the front row to cheer them on. But in a lot of cases, I do the same thing I was doing at live conferences, and just saying like, oh, well, I'm going to sit in the hallway. I'm going to have fun. I'm going to talk to people. I'm going to meet people. And then I'm just going to go binge watch them all on YouTube later.
Adrian, have you seen anything good? What's your experiences so far?
Yeah, well, first off, like when I'm at an in-person conference, I think Justin's right. That's like the way to do it. Try and make the most of the conference track and like watch stuff in video afterwards when you know what's good. But there's always things that you want to go and see and potentially meet the speakers and ask questions. So probably the best things I've seen, I saw a couple of supply chain security talks. If you just search for supply chain security, you'll find it. One was very high level, but gave a good overview of the subject, I thought. The other one was the update on Notary by Justin Cormack and Steve Lasker from Microsoft. And the good thing about that talk was, I didn't know this, but they now have a demo. So there's like a demo of Notary V2 at the end, which, is probably going to be a pretty important piece of infrastructure going forward. And now it's a lot more. One of the problems with the old version of Notary was that the certificates didn't, or the signed, whatever the word is, didn't travel. Signatures, that's the word. It's getting late. The signatures didn't travel with the container, right? So now they've kind of tried to change that so that you can transfer the sort of signature with the container between registries and you don't lose that information. So that's quite a big thing. I also saw David Mackay's talk on Cluster API. So if you've not seen Cluster API, he gives a good overview of that. And then he goes into details about using Pulumi to do infrastructure as code and bring it all up. So I thought that was a pretty entertaining talk.
Yeah, I watched Justin introduce all the sandbox projects, and I've decided he should have a second career reading children's books. I think he's just got a super calming voice somehow that like.
Sure.
Guy, have you done anything for KubeCon this week? You've been watching anything?
Yeah, from a sort of selfish viewpoint, a lot of the sort of community track. So one of my hats is being involved in SEG autoscaling, and like there's been some great talks in the community track so far. There's a couple. There's one more tomorrow as well. But particularly good was one from Ian Coldwater and Kat Cosgrove around communicating changes and how to make sure that you're communicating with the community without causing unnecessary panic, shall we say, for anyone who dealt with people turning up going, I hear that Docker's being deleted. Should I stop building Docker containers, please? So yeah, I'd highly recommend it. Good dose of comedy as well, with them both cosplaying as each other.
Yeah, great. Well, on that note, I'm just going to drop Andreas out for now and bring in our next. Oh no, I'm back to the schedule again. Justin's next, isn't it? Right. We're all good. We can stay for the minute. So, Justin, do you want to get yourself all set up? And if you share your screen, I can give you the power. I'm going to drop some folks out here and drop out Guy. Okay, I think you're good to go. So
Awesome.
Over to you, Justin.
Thanks. So for what I wanted to talk about, I wanted to do a little bit less slides. If you've seen any of my talks, I like to do whiteboarding. I like to be a little creative on a lot of things. And so I wanted to focus on the story that I've kind of experienced from what I'm calling this talk container to cloud, and really about like that initial experience with what containers were to me and how I was using them, and then how we kind of got to this cloud point of what it meant. And my wife has been learning Welsh. I don't know if anyone is here from Wales, and I'm trying to, I wrote it down and now I can't find it. It's Prin. No, I'm not. I'm gonna butcher it. I can't do it. Justin do I am Justin. I don't remember. I'm sorry. I was gonna try to do it and it just didn't work out. But anyway, so my first. Thanks. Wales is here. So we are learning. My wife's learning Welsh, and yeah, I'm learning Japanese actually from this whole pandemic. And so it's just like I don't know if you can get two different languages, and so we still can't communicate. Sweet, I got something right. Anyway, so my story starts here with kind of when I first experienced Docker, and this was mid or late 2015. It was kind of an afternoon, and I was at work, and I saw this thing called Docker pop up, probably Hacker News, might have been some RSS feed, and I was like, okay, what's this thing? Let's figure out how this Docker thing works and what it does and why I might want to use it. And so, of course, I curl to bash the installer, because that's how you installed it. Yes, I got it right. Thank you everyone for the letting me know. That's awesome. I curl to bash the installer, and it did something on my system, right? Like that's how curl to bash works. And of course you have to give it sudo access. But like, what did that do now? Like, what is this? How do I use it? And the basics for understanding like Docker is they have you run this hello world, right? And that's the command everyone kind of starts with. And I'm sorry, I moved my mic. It's right next to my keyboard, so it's really loud when I type, but it sounds like I'm doing a lot of really hard work. Hello world. All right, like that's the command that so many people start with. And it's just like, okay, well, that just gave me a bunch of other instructions of things to do. And if it's just like printing text to my terminal, like I could do that with bash. Like do I need this Docker thing? Like I don't understand the value I'm getting out of this, because it seems like a bash script. And I probably just want to use bash in this case, because that's my first thing that I often do. But let's dig into a little bit more. Let's figure out like, okay, how is this actually working? I hear some people using this. Let's try this command, right? They give me an example, so maybe I should just use that. Okay, now it's slower. Like, okay, now this command isn't, I don't think I like this Docker thing. And it drops me here, and I'm like, well, great. It broke my my prompt. Like, that's not what I wanted. Like, why is it this weird jumble of letters now? Like, my prompt is completely broken. I don't understand what this did. Now what do I do? And that was kind of my thought this first time I'm using Docker. And it's just like, I don't get it. I don't get what the hype is. I don't understand what I'm doing. But then I start realizing that Docker's actually making something really complex, really simple. The more I use it, the more I'm realizing, oh, this is actually taking something like namespaces and C groups and taking tar files, right? Like, tar files aren't actually that complex, but it packages them in a way to make it simple for me to use and to just get started with. And so, like, that's really how I started finding more value out of, okay, if I can make this complex thing simple and repeatable, there actually might be some value in there. So the whole thing with Docker starts here with a container. Like, that's like, most people are like, well, the containers are this. It's a tar file. So I was like, okay, well, my next step is I need to make a container. I need to figure out what it is that I need to do to actually, like, build my own. So if you're familiar at all with Red Hat or Yum, very first thing I do is yum list, pipe that to a Docker file. If you know what that does, that lists every package you have installed on your system out to standard out. And so I could take that and I could just say, well, let's make a Docker file. Like, this is Docker file is what I have to do, make this container. And there's a problem here. Like, this was simple. I got started. The problem was my very first container image was 60 gigs. Not even joking. It was actually a little over 60 gigs. And I was like, okay, maybe I'm not using it right, because this probably is something that I wasn't supposed to do, but it worked. And okay, now I can start to understand how this could be useful for me to actually do something else. So the next thing, like, let's build some more of these things. Let's build some more. Oops, not actually what I wanted. Let's build some more containers. And so Docker, again, takes this complex thing and makes it simple by letting me reuse things, by letting me say, oh, well, actually, you know what? Like, the complex things that a lot of people were doing is trying to figure out runtimes for their applications. They're trying to figure out how to, get some runtime into their application and not worry about the system. So I can say, like, oh, from Python. And that's actually really simple. That interface for me to say, like, oh, well, like, I actually want to use Ruby. And those things started to grow, and I started finding all these cool containers that I could build off of. And I could say, oh, well, actually, like, I want to use these things. I want to do this more because this is easier than building RPM spec files. There was a big problem there of trying to figure out, something that was not a standard. And I mean, spec files were, but, like, not consistent across systems, and saying, okay, well, like, how do I package this stuff? And the problem with this was I started running all. Sure enough, about 2 weeks later, my hard drive was full. I pulled every container from Docker Hub practically. I said, well, let me see what this one does. And just, I kept pulling them out. Okay, like, actually there are some limitations here, and there's some things that this can still break. But that doesn't mean it's not useful. So I start showing some people. And I start saying, hey, like, this container thing, like, let's try to package your application in a container image, and then we'll see what we can do with it, right? And so just like we had VMs growth, like proliferation of VMs, we had the same thing with containers, right? And everyone wanted their own container, and they're like, oh, we're gonna build this ourselves, we're gonna run it. And then because they don't know some of those limitations, they don't know some of those gaps, they fill it with junk. It's like everything is like, oh, well, like, my application needs all of this, and so I'm just going to throw it all in the container, and that's how we're going to work. And it was fine in a lot of cases, but these containers weren't the only thing that Docker was doing. This wasn't the only benefit we were getting out of this. So another thing that we actually got from containers was, as we were shipping this to production, we had to upgrade Docker at some point. And if anyone is running Docker early on, you probably did it and you're like, oh, actually, you know what? Like Docker upgrades were scary because it broke and containers didn't work anymore and production went down. And that was really scary. But thankfully, we were able to do something with that and make it better for everyone by building a standard. And so we could take all these container images and we could make it OCI came. It's like, oh, wow. Like this is actually like a thing I can rely on now. Like these bunch of tar files and metadata are something I can rely on and run in production. And because of that spec, it actually grew a lot more. We wouldn't have got some of the other things we have now without having a base layer spec of this is what a Docker container is. And so now we have things like Helm charts are Docker containers. We have CNAB bundles are Docker containers. Dan's going to show you another demo with some unique use cases of Docker containers. And we can rely on that spec as saying, hey, like this is actually a valuable thing. Like these tars are useful for actually running production systems. But again, not the whole story. Like we had to go from that and now actually like run it in production. And what we used to do early on was we had Puppet or Chef config management, configuring all these systems, deploying systems, VMs, physical systems, whatever, to make them usable for someone. And a lot of times it was like, okay, here's your VM, go pull your repo and run Apache or whatever. Now with these containers, we use the same artifact, the same technology, and we pushed it into our old workflows. And we said, oh, well, let's just use Puppet with some tags on a host, right? With some metadata about the host, and it'll run a container. And now Puppet is our interface to run those containers. So Puppet's doing the Docker run and making sure a container's running. And that's simple to get started because we understood the complexity of Puppet, but it wasn't simple for running at scale. Like Puppet does a great job, Chef does a great job at running systems at scale, but running the applications on top of those systems, the abstractions didn't really line up. And we ended up with a lot of mismatched complexity of, hey, how are we actually doing this? And so we needed a better interface for how do we do Docker run at scale? How do we get that sort of piece of like, fetch the container, do this thing, and now run it? And of course, everyone probably watching this knows the story, right? This is, I have practiced that so many times, and it's still not good. It's like the hardest shape to draw, I swear. So Kubernetes, like there were things before, there's things that still exist. There's Nomad, there's ECS, there's Swarm, there's Mesos. Like these things exist and these things are still there and people are still using them for great use cases. Kubernetes really kind of found a balance between it can do Docker run at scale. And a lot of people, like there is still complexity involved. It's a new complexity for a lot of people because we traded these Puppet manifests or Chef cookbooks. We traded those for a distributed database and an API. And those things are actually different, especially for people running systems. People that ran systems aren't used to that complexity. And so they say, okay, how do I make this piece simple? And that simplicity, in a lot of cases, just comes from like managed services, right? EKS is a way to run Kubernetes in Amazon, and you don't have to worry about the distributed database and the API server and all that stuff. Like Amazon, we handle that for you. And it's a great way to kind of just like, okay, well, you can still run some of that at a fairly simple, scale and or fairly simple interface and reduce some of that complexity and simplify it for the user of the service. And we can say, okay, now we can actually do some more things here by reducing that complexity for you. Kubernetes came along and like Docker container usage, that's a hockey stick up since then, right? Like containers were a thing before, and then Kubernetes made that consistent and reliable, partially from that OCI spec, but also partially because Kubernetes was able to rely on the OCI runtime. another spec from that group saying, hey, like actually this is important too. Runtime is important, and we need to take that into consideration as a spec so that more things can build on it. And Kubernetes, is able to do that because this exists. And the third piece of complexity that containers and Docker really solved was workflow complexity. Say, I want to take my container image, and before, developers had all sorts of mixed bag of how do I ship this code? How do I make this thing work? And now it's build a container, push it to a registry, pull it down. That's it. It's repeatable. That is how we're able to do this. And that workflow reduced so much complexity. If anyone wasn't doing this before, like that, it was a nightmare before of like which application deployed where, how is their build tooling, how does this work, where does this code live, where's the Git repo, all that stuff was complex. And those are the things. This is brand new spec from OCI called the distribution spec. And distribution, bad handwriting there, sorry. But that is this workflow. It actually is a standard for the registry on how we're pushing and pulling images to registry. So now that distribution can be relied on and built on top of. People have obviously been running repos beforehand. It's not a new thing, but it hasn't been a standard until 2 days ago. So here's the other piece. Now people want to take this same thing and they say, well, you know what I want? I want this same workflow, and I want to go to the cloud. Like that's the thing that a lot of people want. And they say, well, like how do I get that thing and just make it go? Because Kubernetes, if you're running it there, great. You can manage that stuff. But for the simple things, for simple websites, for things that aren't complex, if you want it without all the YAML, there are ways to do that. There's hosted services. There's ways we can do that. And I built a little tool here just to kind of show like what I think of when I say, hey, this doesn't need to be complex. And it's just it's a script. It uses standard services, and it has the same Docker workflow essentially of, hey, I want to run something. Here's my container image, and let's give it a name, right? Like, let's say I actually want this to be a published secure endpoint on the web. Like I want to be able to just hit this endpoint later. That's my name. Figure out all the complexity. And I can actually take that package container image. Oh, don't tell me it's going to break. I actually think I didn't delete that endpoint. So of course, we're going to go to complex 2. Because that's what you do. You just increment 1. Let's make sure this gets started this time. But this is the workflow that a lot of people loved with Docker. And this is the reduction of all of the complexity of C groups and tar files and everything else that people had before of saying, hey, you know what? Like, do I need that? For simple things, no. For complex things, Docker Compose exists. That was made. You write some YAML, you integrate some things on your local system. You maybe go do that on a server. For cloud is also a complex thing. There are a lot of tools and a lot of services and a lot of things that exist that make cloud kind of complex. And we say, okay, well, let's simplify this. Can we zoom out from the cloud and get just the pieces that I actually want for run a container? And these things exist. Kubernetes obviously solving that for the complex things, and in some cases solving it for the simple things, depending on how you're accessing it, how you're running it. But this last piece here of, okay, let me simplify how it looks in a cloud environment. That's the tooling that I think a lot of us as developers, whether we're developing systems or we're developing applications, if you're a systems developer, you're trying to simplify this for your developers, for the people using your systems. If you're an application developer, you're trying to simplify this for your users. You probably have a mobile app, a website, spreadsheet, something that makes someone else's life better, hopefully less complex. In some cases, complexity is needed. I'm not saying like just get rid of the complexity. Absolutely, like if I'm debugging a system, I need more information. I need to understand the details underneath it. I need the complexity to be shown directly to me so I can figure it out. But in a lot of cases, some of these standards allow us to focus on just the simplicity of how this could work. So when I look at this and I actually zoom all the way out, go. This is how I like to think Docker impacted a lot of this stuff. It made a lot of these pieces and put them together in a way that we could reuse them. It reduced that complexity. And I'm giving props to them for figuring out how to make those complex things simple in these three areas, especially in those workflows, in that standard of a packaged format that we can run, and in a runtime that we can rely on to build systems on top of. And if I switch back here, oh, it's almost there. Again, hiding complexity is okay. Some of it's automation, some of it's abstraction. That's okay, actually, as long as we give a simple interface that someone can rely on and build on top of. Those are the things that we actually want our users and our other developers to be able to build on. So sometimes we lose some of that noise for like, I need more Kubernetes, or I need more controllers. And some of those things we just say like, hey, let's focus on the simplest thing that you can use. Hosted services, something external, and make that repeatable and reliable for you. Those are the things we really need in our own systems and as we're building things. I swear this is going to work. But really, like, I just want to focus on that of like reducing this complexity, the container image, how the container was able to make some of that stuff. Like if anyone else extracted a container image, as tar is like, okay, I understand the layers, I understand this metadata, linking those things together. In Kubernetes, we can actually do a lot of the same things. We have controllers that link together. It hides some of the complexity. When I make a deployment, what that actually does is it interfaces with 3 different controllers. It automates 3 controllers together. It says, okay, well, here's my deployment controller that's going to build me some replica sets. Those replica sets are going to create pods. Those pods are going to get scheduled. And so I have these different controllers that interact together to make complex things simple as an interface. And so definitely keep focusing on what makes things simple for an end user and for anyone that's using your systems. And hopefully this is actually running. Yep. There it is. There's that workflow. That's what we wanted, right? We ship those containers to something simple that looks like it runs in production. And it doesn't actually matter in some cases if underneath the hood is something a little more complex, something that someone has to figure out, but in each of their own little areas, they can simplify it for themselves. They can understand, oh, actually, I just run this load balancer piece. I just run this ingest piece for traffic. I just run these Kubernetes bits. And creating all those complex things into something that's simple is really the goal for a lot of our systems. So I'm encouraging everyone, don't throw away the past, but look at how we can build simple things on top of these complex systems and giving people that interface in the workflows that can simplify for everyone. So that's it. Thank you.
That was awesome, Justin. Thank you. Let's add some folks in here. I think we've got some people who've probably got some opinions about complexity and in systems. Let's bring Kevin Jackson in here. Hey, Kevin, another veteran of the OpenStack era. So
yes, you can tell by the herd.
And let's bring Dan Finneran in as well from Equinix and get our hosts back on. Yeah, there were a whole bunch of stuff in there that I thought was really interesting. I do think I've been surprised, to be honest, that we're not seeing more abstractions being built on top of Kubernetes to make things super simple. It's like, because it's like, where's Heroku, right? Because I mean,
and that's for some people is I push code and I get an endpoint, and that's great. Like that is a goal for a lot of people, and that simplifies a lot of things for people because they don't even care about the container. The container allows you to do somewhat complex system things inside of a reusable formats where I maybe can't do that in a Git repo.
Yeah, absolutely. I mean, I remember from I don't know whether you remember this, Kevin, but when Kubernetes first appeared, and I guess this must have been when Mesos had kind of only just appeared as well. There were people doing talks at OpenStack summits about running Kubernetes on top of Mesos on top of OpenStack, which was just like, what?
Well, yeah, exactly. I mean, the way I like to see the, where Kubernetes, or why Kubernetes exists today is the fact that those technologies back then just didn't solve all the problems. We thought they did. We grew up in an era where there was, the data centers, and they want to break out of the data centers, use more software-defined type of approaches. And then we had the cloud kind of like era. But then there was software in there. It just didn't quite fulfill all the goals of what cloud really should have been. And that's why we end up with systems like this.
Yeah, indeed. What are your thoughts on this, Dan? I mean, you wrangle hardware for a living, which must be even more complex, right?
Yeah, I mean, it's kind of been a bit of a weird journey almost in some regards, and that I was at Docker and then I was at Heptio doing Kubernetes and kind of being part of some of the standards and things like that, and now kind of it's interesting. Justin kind of alluded to the fact that we are trying to take bare metal and kind of use some of these standards. So kind of being able to make use of kind of the OCI spec in order to have and just automatically get all the benefits that kind of come with those specifications, and being able to take what has effectively been kind of old and slower ways of managing bits of infrastructure and kind of forcing it into the light and into the future by adopting these standards and building bridges in the kind of building a bridge from old to new ways by being able to kind of get these standards to work with kind of older infrastructure or infrastructure that typically never had APIs or was typically kind of quite hard to manage.
And focusing on those workflows, right? Like that's a big benefit. Like cloud native isn't all about like you have to run in AWS. Like you can get the same workflows and use some of the same tools wherever you are, which actually gets a lot of the benefit sometimes, because you'll have hardware failure just like you'll have an EC2 instance get retired, and both those things you can handle with systems that can adapt and adjust to as long as you can move from how am I managing this file system to looking at it more as a API in a database, like how applications are running. Like that's the big shift for a lot of people from this cloud native, from on-prem to cloud native is being able to say like, okay, well, like I don't run agents and deal with POSIX as much anymore. I deal with APIs in distributed databases, and being able to automate based on those APIs instead of files on disk is a big change for a lot of people.
I mean, I still often think when I look at YAML, though, if I'm, if I'm an application developer, how much of that YAML do I actually care about? And often I come to the conclusion that actually I don't care about any of it. I don't even care about the image, right? I just care about something to run. What do I need to run? What runtime do I need?
And that's where complex things are still complex. It's not like Kubernetes doesn't necessarily hide that. It allows you to have the freedom to build complex things. And if you're doing something complex, it's still currently, in most cases, complex. We build operators and controllers on top of it to make it automated and to give you a consistent interface, but it's still a complex thing. And so we're not really hiding that in a lot of cases. But for the simple, website here of like, hey, can I host a static site? Like, yeah, like that's not a problem. Like, I built that container in 10 minutes. Like that was an okay thing to do. And it's just like, okay, let's post that. Businesses are typically fairly complex. And so you're going to have some complexity, if not from the systems, from the people involved with those systems. And we don't necessarily need to hide all that. We need to figure out how to make those things simpler as much as possible to scale. But like, I'm not saying there's no complexity involved. I'm just saying, let's find the things that can be simple and not make them complex.
Do you think, and I've sometimes thought that Kubernetes has ended up suffering from the same thing that OpenStack suffered from, in a sense that it starts off with a relatively simple concept in the sense that it was originated to be a super simple application deployment mechanism. And then because it becomes this kind of generalized thing that has to, by its nature, cope with almost every use case, it ends up becoming incredibly complex.
Yeah, Yeah, I agree. Yeah, we saw it in OpenStack. We see all the vendors' input. We see all everybody's input. I think there's a level of inevitability. I think there's a level of foresight as well into this. I don't know what the answer is, though.
I mean, I think to a certain degree, the thing with Kubernetes almost, though, is that you don't necessarily need all of the parts. So, I mean, it can be as complex as you want it to be. You can start to introduce more and more controllers to do more and more things, and it starts to kind of become that car from the episode of The Simpsons where they've, kind of bolted on far too much. But ultimately, just kind of the API server and the scheduler, kind of get you the bare bones kind of bits that you need. You can kind of take it as far as you want. So, I mean, it really depends on hopefully kind of what your end goal is. And there's been kind of two interesting kind of things discussed at KubeCon. One was a project called KCP, I think, and the other one was a project from Jason de Tiberius, which was effectively to take the API server and cut everything out of there that he didn't need anymore. And that effectively gives people kind of the bare bones for having, kind of the reconciliation loop, and making their own API server to manage a completely different type of objects and things like that. So you get all of the goodness, but you get the capability of kind of customizing it for your own ends, for your own needs.
Yeah, I remember there being a talk at KubeCon. I must have been one of the first KubeCons I went to about the API being the kind of the really important bit, and the actual things that the API controlled was in a way secondary to the fact that it really gave you a universal way of describing things, and that was a super powerful concept to be able to apply the API definition to lots and lots of different things. And that's certainly what we've seen over the last few years, isn't it? More and more objects, and
it really, like, that comes down to standard, right? Like that's the piece that is beneficial. And to what Dan's point was saying earlier, like Kubernetes, like cars are complex. Like cars are very complex things. If I open the hood of my car, like I used to work on cars, so I know what they do, but like most people don't need to. Like they're like, I have a steering wheel, I have some pedals, and I have a gear shift. And that's what I need to use the car. Those weren't standard things up until the 1920s, right? Like Henry Ford, like they were used to, I mean, well, granted, we're a mixed audience right now, so we're still driving on both sides of the road. Like I can't take my car and go drive it, in the UK, because some things are going to be different. Like like we're using miles per hour and driving on the right side. And like those things aren't standard everywhere. I can't use a car everywhere, but I know fundamentals of like, I can do this thing, I can push this pedal, and I'm going to go somewhere. And being able to standardize on how those work and how those interface. And we've taken that general interface of a steering wheel and pedals, and now cars drive themselves. And they still have steering wheels and pedals in a lot of cases, because like that's the standard interface for there's an emergency, I need to break glass, I need to do something, so I'm going to have to like take over here. And like that interface has taken us very far. And Kubernetes as the API, I think, can do just the same thing for distributed systems.
Yeah, great stuff. Well, I guess we should move things along and get on to our next talk from Dan. Before I give you the stage, Dan, is it true that the roots of Tinkerbell were basically because OpenStack Ironic didn't work properly?
I don't actually know that that's the case. I think the Tinkerbell project is effectively kind of the secret source of Equinix Metal, or formerly Packet. So all of the kind of, well, not all of the code, but most of the code of Tinkerbell is what, when you went to Equinix, when you went to Packet and asked for a bare metal server, that was kind of the core engine that would go and handle all of the provisioning work, that kind of handled all that. And I think, given the age of Packet, I think they kind of probably started developing all of what became Tinkerbell kind of around the same time that Ironic kind of came
I think I remember a blog post bemoaning Ironic at some point, and why they then decided to write their own.
Well, that's before my time, so I have no comment about these sorts of things.
Right. On that note, I'm just going to drop some folks out here. We'll reconvene in a minute. And where are we going? Remove. There we go. If you want to share your screen, Dan, and I'll right over to you.
Right then, thank you very much for having me today. I'm going to kind of kick things off. I'm going to try. There's a combination of kind of slides and live demos that I'm going to try and do. Fingers crossed this all kind of goes well. I've had a bit of an interesting day with things breaking, but let's kind of kick things off. So, wrong way around. There we go. So, Tinkerbell. Today I'm going to be talking about Tinkerbell. And to begin with, my name is Dan Finneran. I'm from Equinix Metal. So I'm part of the DevRel engineering team inside Equinix Metal. We tend to focus a lot of our energies on kind of the community side of Tinkerbell and working on kind of the ecosystem integrations for bare metal and integrating bare metal with kind of other cloud products and things like that. So as I mentioned today, I'm here to talk about Tinkerbell. So as I kind of briefly just mentioned, Tinkerbell is a project to look after and manage bare metal. I have to put this slide in all of my presentations pretty much by law, but Tinkerbell effectively, as I mentioned, was an internal project developed inside what was Packet and Equinix Metal. When you go through the UI and select a piece of hardware that you would like to have as a resource, as a piece of infrastructure, the components that were underneath there would effectively manage all of the provisioning work, the post configuration, the deployment of the operating system and the bindings and installing all of the keys, etc. And from that, you would effectively be given a piece of bare metal infrastructure through all of this underlying technology. It was decided around a year or so ago that it would be a fantastic idea to kind of open source all of this technology. So it was decided to effectively take all of the secret source, the magic source, rebrand it, take most of the things that kind of tied it to the Packet infrastructure and open source it as a project called Tinkerbell. And why the name Tinkerbell? Well, that's because it's powered by pixie dust. We have a bunch of other projects. We've kind of followed down the Docker route in terms of keeping things in a naming convention. So you'll see some of that a little bit later on. So what is Tinkerbell? Tinkerbell is a workflow engine. And these workflows are effectively designed to execute a series of actions on a remote host. So what that effectively means is that Tinkerbell will pass these workflows to a host that you are wanting to provision on, and it will take care of them running those actions on that host. Tinkerbell is effectively a number of microservices. So it's around 6 or 7 different components that all take care of different parts of that, whether that's IP address allocation, whether that's actually managing those workflows, whether that's being kind of the UI, the CLI, etc. And then there's a number of additional tooling that we've put around the Tinkerbell ecosystem to make things a lot easier. So whether that's building specific kernels for specific hardware, or actually creating your own operating system images to actually deploy. So how does it actually all work? Well, when you power on a server for the first time, it basically has no knowledge of anything that it should be doing. So if there is no operating system on the disk, or you have specifically told it to boot from the network, for instance, the server will basically have no unique identity. It will effectively go to the network and ask the network to provide it with that information. So with Tinkerbell being there, this is effectively the steps that one would go through. We pass in the hardware configuration that we know about. So for this instance, we're aware of this server. We pass in its MAC address, which is a unique identifier for that. And then we pass in a workflow. And this workflow is the list of actions that will be executed. At which point then, when we power on the server, one of the microservices called boots will be aware of this piece of hardware at this point, where it will use a number of different components in order to bring up that server in a state that we can actually make use of it. So DHCP will give it an IP address, TFTP will send over the kernel and RAM disk, and HTTP will be used for additional things. So what is actually sent over to there? We send over an in-memory operating system, which is a kind of a read-only operating system that is sent over TFTP to that machine. And inside that in-memory operating system is a component worker. And the Tink worker's job, once started, is to effectively then reach back to the Tink server and ask for that workflow. So once it's asked for that workflow, the Tink worker will then go ahead and execute all of the actions that are in that workflow. And under the covers, what are actions? Well, effectively, actions are Docker containers, and they can do a number of different things. So we have actions that may wipe a TPM, do secure cleaning of the disk, so 9 writes to the disk, etc. Partition, stream things to block devices, and then perhaps reboot or kexec and things like that. So kind of like Neo in the Matrix, once he's plugged in, we can effectively push operating systems, push config over to those machines. So deploying on bare metal, kind of what does it look like? Well, I originally have been wanting to do Windows 95 as a demo. Unfortunately, it's kind of physically impossible in this day and age. Windows 95 will panic due to the fact that machines have far too much memory. But we'll kick things off by effectively doing our first demonstration. So just to explain what we're looking at here, we have 2 VNC windows that are connected to the remote console. I apologize that these are quite small. There's not much I can do to make them much bigger, but there's 2 machines, one on the left, one on the right. And the first thing that I'm going to do, I'm going to go to my Tink server here. I have a number of different operating system action workflows that are on here. And the first thing that I will do is I'm going to apply a workflow to the machine on the left. And that workflow is the Windows 2019 workflow. And now I can effectively connect to the machine. And what I will do is I will get the machine to reboot to Pixie booting, at which point Tinkerbell will be able to provision through that workflow. So what's actually going to happen now is this machine on the left will power cycle. We should see it come up to the BIOS in a second. There we go. So Tinkerbell is now effectively going to take care of provisioning all of the things on that machine. This window will bounce around a little bit. Before I kind of carry on there, what it's actually provisioning is an OS image. So as I mentioned, we have a number of projects to make all of this easier. And as I mentioned, we try and keep these within the naming of kind of the Peter Pan universe. So we have a piece of tooling called Crocodile, and the point of Crocodile is effectively to build machine images. It effectively makes use of Docker and a tool called Packer from HashiCorp. And we recommend running it with a few kind of volume mounts to pass through and things like that. And if you kick off the Crocodile container, it will effectively give you a list of operating systems that it can build. And if you select any of them, it will take care of getting the ISOs and provisioning things and doing everything that it needs to do. It also has a fast mode. Ooh, I can't see that. And if you use the fast mode, the Crocodile goes red, and that will allow you to provision some things a little bit quicker, but without some of the enhancements, which makes it quicker to provision. All of the finished outputs will then be in the images directory. So we can see here, we have a bunch of operating system images. So that is the kind of tooling to manage all of that. So one of the things that Justin talked about was OCI registries. One of the things that we have a number of different actions which provide us different ways of provisioning things. The most common is to stream one of these OS images directly from a HTTP web server. However, recently we've added the capability to push these OS images to a registry. So I'm going to quickly push ESXi to a registry. So inside my web root, we can see all of these images. I'm using a tool called ORAS, which is OCI registry as storage. And if I look inside my hardware registry here, it's logged me out, that's helpful. If I go in here, we can now see I've just pushed ESXi as an image. And what I can do now is I can specify another workflow on my other piece of hardware. So I've created a new workflow, which is going to use the OCI to disk action. And I can now go back to the UI here, connect to the other server. One second. Power actions. We set that to Pixie, and now that will follow the exact same path. So this machine on the right will reboot in a second and start provisioning. So what's actually happening on these machines at the moment? So the machine on the left has booted into the in-memory operating system. I did a talk about this a couple of days ago with Justin Cormack. And the reason why I gave that talk is that we recently replaced all of this in-memory operating system with a kind of newly built piece of technology. And we effectively are making use of a tool called Linux Kit. And this provides us a bunch of additional functionality in that it becomes very quick and very easy for us to stream. Oh no, what have I done here? One second. So this is a issue with Nux. Can I power this one off? Nope. So what's happened on the machine on the right is it's joined my network at 10 megabits because I was connected to the VNC instance before. This is a bug in Intel AMT in that it. Oh, come on, demos. Okay, we'll wait for this machine to reboot. Effectively, there's a bug in the Intel AMT, which is the BMC, which means that if you're connected to the UI, when you turn it on for the first time, it will join the network at 10 megabits as opposed to 1 gigabit. So I should be able to power cycle this and join it back at the correct networking speed. But as I mentioned, under the covers, we're using a tool called Linux Kit to build that in-memory operating system, which means that we can build these operating systems very quickly in both x86 or ARM. So Tinkerbell will allow us to provision on both x86 quite quickly and on things like Raspberry Pis. So once this is finished rebooting, I will power it off and then I can start it again properly. Come on, Ubuntu. The demo gods are not with me today, unfortunately. This thing back up again. Okay, so this is back up again. Okay, so in the interest of time, I only have a kind of couple of minutes left anyway. I am going to shut this in OS, this piece of bare metal infrastructure down. Once it has gone off, I should be able to It's looking like both of my demos have broken today. Oh dear. Okay. Unless that comes on in the next second or so, I'm just going to have to kind of quickly step through this anyway. So I'll pop back after this anyway. So in the meantime, other things that we've been looking at, as I mentioned, we're looking at being able to push OS images into OCI container registries. We do this through the ORAS project. As I mentioned, that's the OCI registry as storage. We've been looking at using a project called CodeSign, and CodeSign will allow us to sign those OS images that live within in those registries, so we can start to effectively have chains of trust, so knowing where those OSs come from. As I mentioned, with the Crocodile project, we can start to put all that OS image building into pipelines and automate all of that, have that done through kind of CI/CD. The Hook project that we're using LinuxKit to build, because of using the LinuxKit technology, we can effectively enhance that quite easily by adding in additional containers that will provide metrics and additional kind of debugging technologies. And then finally, most of the actions that I talk about are around provisioning operating systems to disks. So either using things like the image to disk action or the OCI to disk action. We've actually seen some other kind of ways of working where people put their applications into an action. So effectively, no writing to the machine or anything like that. Tinkerbell will actually start the application remotely on the remote host and effectively make use of the CPU and memory there. So instead of installing an OS or streaming an OS, we effectively can just run that application remotely on the remote host, which I like to coin as OS-less, not serverless. But it's basically one kind of new way of, or one way that people have been looking at actually making use of Tinkerbell actions on these remote hosts. So it doesn't look like my machines have come up. Oh, it has come up. We'll kick that back off again. If anybody has any questions about both of my failed demos, that's fine, or anything else that I've kind of quickly kind of gone over. In my defense, my lab did blow up this morning.
I feel for you, Dan. We've all been there. Demos and hardware. The two hardest problems in with live stuff. Yeah. This should come on. If this does, just quickly, the machine that's rebooting on the right, the kind of reason why this demo is important is that, if it works, is that this demo is, it shows kind of one of the quick technologies. So this kind of shows how Cluster API Tinkerbell works. Cluster API is a provisioning standard that the Kubernetes cluster SIG cluster lifecycle are talking about. And we've been working on a provider which will effectively allow you to provision Kubernetes as you would do on AWS with Kappa or on VMware with KapV, using Tinkerbell in the same way. And effectively what's happening, and this is actually working finally, this is streaming an OS onto a piece of bare metal. This should take another 10 seconds or so. Once it's finished provisioning, there's no reboots or anything like that. It uses a technology called kexec, which will flip us directly into the provisioned operating system. So with Cluster API Tinkerbell, we make use of the image builder project from upstream, which allows us to stay lockstep with how all of the other providers are doing it. And we can then provision directly into those. So usually, if this is going to work, it should happen any second now. It basically allows us to provision kind of Kubernetes nodes in kind of around a minute or so, and then flip directly into the provisioned system. But it looks like nothing is working very well for me today at the moment. So we've got a question from the audience here, Dan. Sure. What sort of scale can Tink deploy to currently? That's a very good question. So at the moment, as mentioned, Tinkerbell is underneath various parts of Equinix Metal at the moment, which is arguably one of the larger bare metal cloud providers at the moment. So it can scale pretty largely. There is not a lot of kind of things that limit it to scale. The main things really are going to be
provisioning large amounts of infrastructure at once, you'll get bottlenecks in terms of pulling both the kernel and the RAM disk to the machine that you're provisioning at that time. But yeah, I mean, at the moment, it is kind of being used in various places. And it's kind of funny, we keep finding out from the community, various other places, that it's actually being used as well. So there's some cloud providers that are actually starting to use this under the covers. We don't necessarily always get made aware of it. But every now and then somebody from the community, kind of will reach out and start kind of asking us if we can kind of quickly hop on a call with them. And it turns out that, they're doing a bunch of stuff with it. So it looks like it's actually finished provisioning this machine here. If it works, it'll kexec directly into it. If not, I don't know why things are behaving not as they should be doing at the moment.
This reminds me of something that happened before, Dan. Can you remember the time I think you ran a DHCP server in a hotel?
Yes. So kind of one of the reasons I ended up at Equinix Metal was that when I was at VMware and Heptio, I ended up having a lot of focus on kind of bare metal Kubernetes clusters. And I went to go work with a customer who wanted a bare metal Kubernetes cluster, but just didn't want to know how it worked. So through that, I ended up basically writing my own provisioning engine using DHCP and things like that. And I was in a hotel in Germany, left my laptop running. When I came back, their conference suite, they had these digital conference screens, and all of the conference screens were all at Linux prompts. When I got back to my machine, it turned out that they were all set to reboot at a certain point in the evening to pick up the new config, and my laptop had basically overwritten Linux to all of these machines inside the hotel, which was awkward. I didn't know whether I should have said anything or not, but I just kind of quietly checked out the next day.
Walking past all these broken screens.
Yeah.
Another question here. I don't know whether this might be a bit big to fit on the screen here. Can you see that one, Dan?
Yes, I can. Yep. So the way that it works, and this is the same way that all of the cluster API providers work, is that typically inside the OS image that is created by the image builder project, so like AMIs for AWS, VMDKs for VMware, etc. The image builder project will build something like Ubuntu 2004 or whatever, and in there is kubeadm, kubelet, kubectl, and also all of the images for that particular version. So the OS image has everything in there that is actually required to get things actually up and running. The next steps really are whatever technology will provision those onto provision up the VMs or write those to the block devices on bare metal, and then using tools, technologies like Cloud Init, or sometimes it's even remote SSHing into the node. It will effectively do the kubeadm inits to bring up the nodes, get all of the tokens, and the cluster API providers will take care of then doing all of the necessary post-config steps as those machines actually come up. And the way that the upgrade path kind of all of that works is basically remove one, add in the newer one with a newer version, add that into the cluster, take the next one out, and so on and so forth.
Great stuff. Any more questions for Dan? Thank you, Dan. That was great.
Thank you.
Super interesting. Thank you. Right. Last but not least, we have Kevin. Let's make some space on the screen here. Welcome.
Thank you. Thank you, everyone. Thanks, Matt.
If you share your screen, I can get you all.
Hopefully that looks about right.
Right, I shall leave you to it.
Thank you. So yeah, thank you, everyone. Thank you for inviting me here. I think the last time, I was presenting with Matt in the room. I think it must have been about 6 years ago. I was talking about OpenStack. So how things have changed. So I've come to talk to you today about well, to answer this particular question. And before I start, by the way, I don't have any demos. I decided just to come with like opinions and terrible humor. So hopefully, I can nothing will go wrong apart from the humor. Anyway, do I need to back up my Kubernetes app running in the public cloud? Easy question, right? Because this is a lightning talk, I thought I'd just get straight to the point. The answer is obviously yes. But yes, and this is a big but. What can I say? I like big buts, and I cannot lie. I told you I'm coming with terrible humor. I did warn you ahead of my talk. But the real question we really need to answer is, how effective is my public cloud app architecture backup and recovery strategy? Oh no, my PowerPoint presentation has failed. It looks like I may need to pull back my PowerPoint from my backup. I'm not a good actor, by the way. Obviously, this is fake. But I am going to use my provided backup solution that's been provided to me by my provider. In this case, my provider is my Mac. I have a light and lovely interface to recover my workloads. I can choose which apps, which documents, which folders to recover, and it does the job. It is good enough. But it's good enough until it isn't, right? So obviously there's pros and cons to the provided solution as part of my Mac provider. Okay. So what are those pros? So obviously, this is free. It's part of the platform. So of course, as good boys and girls and everybody else, we're gonna be backing up our files and our directories, our hard drives. And so, of course, we're going to use the tools that are immediately available to us. So this one is free, low cost. You can't get much lower cost than free. It's, of course, easy to use. It's part of the operating system. Macs are, relatively easy to use. And, of course, they ultimately, I can recover my file. So, thumbs up there. There are downsides, right? My restore options are limited to just my Mac. I can recover my files to my Mac. I can recover my files to my Mac. So it kind of like limited if I wanted to recover my files to my Windows laptop, or I want to recover my files to my Linux desktop. Actually, I told you I should have stopped with the jokes. Linux on the desktop, that's obviously going to be next year. And obviously it's rather basic. I don't have much control over what is being backed up. I can choose to back up my hard drive. I can choose to exclude various things, but it doesn't really give me, much control over, just watching my PowerPoints, watching my Word docs, watching my whatever important files, that are important to me on my particular platform. Now, obviously, this is obviously a very contrived example, just to inject and kind of like set the theme and give me a chance just to tell you how bad my humor is. But if we take the same kind of thought process into the cloud, into the real world of where you're actually running your applications, we have to have further thought on what is good enough. So considerations for cloud native public cloud backup. So first thing you've got to consider is, what does my backup actually cover? There's obviously there's features and tools that talk of, say, cluster backups, but a backup is obviously only as good as the restore. I know that was corny, but of course anybody in the backup industry, anybody in worth their salt has probably used that phrase probably way too many times. Does it cover my application? Does it cover the complexity of my application? Does it cover the persistent volumes? Does it cover what's important to me about the reason why I'm running my applications on the public cloud in the first place. You know, usually, mostly, that is to make some money for your business. How do I invoke my backups to cover what I need when I need to? Is there, you know, a good workflow, a good API to able to perform my backups in a way that I need to invoke these backups? So is it something that runs in the background? Is it something that just part of the infrastructure that's provided by my cloud platform, and I just don't have to think of you know, anything more than making sure that it's turned on? But crucially, and going back to my point again, in terms of like a backup is only as good as the restore. I mean, what does that restore really look like? I mean, if we're talking about the backup of my public cloud cluster, my private cluster where I run my important applications, the complexity of my applications, what do the steps involve? Does that involve additional team members? Does it involve additional calls to storage? Do I have to glue things back together? If we start to look at what cloud native backup really means, a lot of it is down to the fact that we need to capture the right data, the appropriate data. And I think crucially these days, it's absolutely about the workflow. It's not about the fact that there is some storage I can recover. It's a hell of a lot more than that. It actually has to be part of recovery process. It has to be part of the way that your business will then get back up and running in a fast and efficient way. What happens if a region is unavailable? Look, this is not, honestly, you know, when I put this in, I'd envisage comments of fear, uncertainty, and doubt. But ironically, you know, if you think about the backup industry, we rely on fear, uncertainty, and doubt. But that said, and genuinely, you do need to consider the fact that things do fail. Despite the best efforts of all these amazing cloud providers, they are not completely infallible. And ironically, the times when something really goes wrong that was unexpected, they're more complex recovery processes, and complexity leads to lengthy outages and mistakes. So in terms of utilizing what you have in terms of your public cloud and what you have available as part of the offering, you have to start looking at what a disaster recovery plan also looks like. You know, if you look at the Azure AKS documentation, where they talk about business continuity and disaster recovery, they openly talk about third-party tools. They openly talk about making sure that your data is available in secondary regions. It's not a given just because it's cloud that it's going to be highly available all the time, as fantastic as those services are. And lastly, are my recovery options limited? Now, I think it's easy to think of this in the context of a multi-cloud strategy. Yes, I know everybody's been talking about multi-cloud for God knows how long, 15 years, I don't know, or more. I genuinely think, with the advent of Kubernetes, with a high degree of portability, I think, we may actually see the decade that people actually do have hybrid and multi-cloud type of strategies. But that said, it does bring into question that you have to start looking at something that is much more cloud agnostic when it comes to backup and recovery. There's nothing stopping you having a tool or tools that allow you to provide backup and recovery options that are seamless across multi-cloud vendors, off-prem, public cloud, and multiple private clouds. So typically what we tend to hear about when we're talking to customers around public cloud backup, are the ideas that the cluster is backed up. But public cloud providers obviously will provide a level of backup for the clusters, but it doesn't include your applications. Again, going back to, I feel sorry for picking on Azure, just one that I happen to be working with today. But they openly state use third parties to back up your persistent volumes and your applications. So, you have to start looking and going down into the details and understanding what you actually get for your money in terms of the backup options available to you. I use snapshots, so my data is backed up. Yeah, funnily enough, snapshots are not backups. I will repeat this. Snapshots obviously are not backups. We have to think of failure domains. At this point, we look at snapshots. You've got your storage. You've got your snapshots. On this cloud storage. Well, first and foremost, it's all the same failure domain. Secondly, it's also within the failure domain within the data center and the regions. And so you have to start considering the scenarios of what happens if this particular data center fails. I mean, there's well-known use cases. Unfortunately, data centers like the ones that run in France, they go on fire now and again. So again, you have to start thinking about worst case. I'm not a doom and gloom merchant. I'm just an architect. But you do have to start thinking about these kind of like scenarios. But again, snapshots are not backups. They have absolutely their use in life. But a backup has to exist outside of your cloud environment to be effective. Cloud provider is HA. Of course they are. Of course, cloud providers are HAs. The reason why you chose them, you can send your commands to these cloud providers. You can launch your instances as and when needed. So of course, why would I need to protect it if it's all magically a HA in the cloud? Well, I know we don't have to preach to everybody in this audience. HA is not data protection. I'm putting this in for completeness. I'm putting this in for the fact that I'm sure marketing has asked me to put this in. But hey, HA is not data protection. It's replication. It's ensuring that the servers are available for that moment in time. It does not have any bearing on your backups whatsoever. In other words, if we start to think of, say, HA of the storage, that's almost likened to the fact that I don't need to back up my home computer because it's RAID. Okay, so if I delete my file on my hard disk, guess what? It just replicates that deletion. So of course, HA, we don't have to preach, but HA is certainly not data protection. So this is a lightning talk. I wanted to talk to you about the fact that do I need to back up my Kubernetes app running in the public cloud? Well, yes, it's an emphatic yes, but it has to be an effective backup strategy that doesn't limit your ability to recover your applications and data when you need to, where you need to, and how you need to. Thank you. Questions?
Thanks, Kevin.
Welcome.
Don't think we've got any questions. Aren't all applications stateless these days, though?
Of course they are. That's just cloud, right? If you think of the early days of cloud, hey, you don't need to run databases in the cloud. And guess what? We have customers who run like Oracle databases now on cloud platforms. It's in one respect, it's kind of like ludicrous. In the other respect, this is just the way humans work. So we have to deal with them in the most appropriate and efficient way.
Great stuff. Thank you for that. Thank you for joining us. That's brilliant. Lewis, I think you've got a couple of pieces before we close the show, haven't you?
Yeah, just some points of order. But to build up to it, I guess. And it's amazing seeing all the speakers today because I've seen you all like from afar because I'm joining this party, it feels, and it's great seeing you all today. But equally with Justin, because Salman Iqbal, the other co-founder of Cloud Native Wales, we were going on a train between Bristol and Cardiff. And when we started Cloud Native, we were reading the Cloud Native infrastructure book that you wrote. So it's lovely to have that loop. And also thank you for everything that you did with Disney, because that's saving us now that we've got young families. That is invaluable in the mornings. But One of the other things that you do quite a lot of is contribute towards the community. And I've seen you on Twitter Spaces recently with your CFP. Well, you did a thing on CFPs, which is invaluable. So from all the talks that we've had today, from the stories of scaling, the way that you did the breakdown about containers in the cloud, to the live demos that Dan did, and that was epic. Right? Like, honestly, I was rooting for you all the way. I love it when that happens, and you did awesome. And then the slides with the exceptional humor at the end, like that humor that's just up there for me. That was perfect.
Next level.
Yeah, but because I am the Welsh one here, so it was Justin Adui, I think you were going to say, which was my name is Justin. I'm getting a little bit of my depth. We've got Alid here as well, who would be able to help you out however your wife needs with learning Welsh. But to also help out, we've just created you a little page. So if I just get this up quickly. So we've been working on HackMD, the Welsh contingency of us. So we love rugby. Not to rub it in any other country's faces, but we'll just say that for another time. We know you like your movies as well, so we've got some Welsh ones here. Twin Town, that's not a family-friendly one. So just watch out for that. Just some people that you might know of in LA who for some reason have left Wales and now live in LA, but they still come back occasionally and they put stuff on Instagram. There's some TV shows. But the one thing, and I think this is for everyone now, have a listen to Gorky Zygotic Monkeys tonight. The Patio song is the most beautiful English to Welsh song. Everyone can enjoy it. We all need to have a little bit of enjoyment. But then just feel free to work your way down. And and if you want to have a Welsh night, just get some cheese on toast with a little bit of beer on it. That's Welsh Rarebit, you're good to go. But so just to that. But with your CFPs, sorry.
This is amazing. Thank you. Actually, my wife's birthday's in a couple weeks, and for Mother's Day, I ordered her some Welsh cakes. There's a Welsh baker that's like here in LA, and I was like, this looks amazing. Like, I'd never heard of this before, and so I got like the big basket of all of the different types because I'm so excited to try it. So this is fantastic.
So I got a Spanish friend, just to say, who keeps shouting at me that Welsh cakes aren't really cakes. So just set expectation levels. I think they are delicious, but just to keep them there. And that baker must be doing really well for themselves. So that's awesome. But back to those CFPs as well, for everyone who's on the stream, I'm thinking, because we've all been locked away for quite a while now, and I'm sure you're itching to get out, seeing all these talks, seeing everything that's happening. Look at getting some CFPs ready, because we've got some really big things lining up later on in this year. And just get them ready to go straight away. But to that, I'll pass back to Matt.
Yeah, thank you, Lewis. And Justin, I'm sure Lewis will share the link. It's actually in the shared doc that we have behind the scenes here. So
I'm about to tweet it now, because it's for everyone. Like, this is Welsh culture for everyone. Like, this is.
Well, I have to hold my hand up, as you know, Lewis. I grew up in Wales as well, so I did laugh the other day on Six Music when someone pronounced Gorky Zygotic Monkey as Gorky Zygotic Mincy. It's a new way of saying that band name, but that's fantastic. Good to know. Right, so all that's left for me is to wrap up tonight by thanking all of our fabulous speakers, Justin, Dan, Andreas, and Kevin. Thank you so much for joining us. Thank you to all the folks who've watched the stream, and thank you to my lovely co-hosts. And I must thank our sponsor, Sneak, who not only pay my salary but sponsor this show, which is always nice. On that note, please do, if anybody who's listening, if you have lightning talks that you'd like to give at upcoming events, please do get in touch either on Twitter or on #CloudNatives UK on the CNCF Slack. We are in the process of organising our July event. We haven't finalised the dates yet, but we will be finalising that imminently and putting it out on all of your meetup groups. So, I think that's everything. So, see you later, folks.
Bye.
Thank you.